architect, because the title of software architect is right now in trend. And a lot of IT people are also here in this meeting, so probably know what I'm talking about. And I go up to the lens of convincing them that I'm not a software architect, I'm just a building architect, not just a building architect who uses softwares. So they get convinced pretty easily at one point. And the problem is they see me working, and then they ask me a few questions like, aren't you supposed to be doing drawings? Or aren't you supposed to be printing and making hand drawing and hand sketches? Why do you need a laptop? And sometimes I even get questions such as, why do you need to know a programming language? To all these people, I always answer this one question. And that is also one of these questions which Ankur just asked me, what I do. The answer to all those is, I'm an architect. I'm just using technology to design. Good evening, ladies and gentlemen. My name is Kaushik, and I'm an architect at Modfive Labs. So a couple of small introductions, which what I would like to start with. My partner is Parmesh. He's a specialist in vernacular design, and he's trying to combine what parametric architecture does to vernacular architecture. Vernacular is basically the local architecture for every place. And the other partner I have is Sai Harini. She works on the efficiency and sustainability side of our company. And we also have a few mentors who guide us on taking these ideas and bringing that into the real world. Yoganand Selvaraj, Mr. Ramesh Ramachandran, and Sampath Raj. They all guide us in various forms. So at Modfive, what we actually try to do is we design and we do a lot of research and on architecture and architectural processes. So what we're actually trying to do here is trying to bridge the gap between architecture, design, and technology. So, and that is basically one of the major goals of Mod5, where we try to bridge the difference between the gap between design and technology through various means. So talking about design and technology, I would like to start with the evolution of how design has been going on all these days. If you look at the first picture on the left side, you could see that this is how architecture actually started in the first place. We were all drawing things, drawing all the diagrams manually. And sometimes even the sheets were bigger than us. So we had to lie down on huge tables, and it was like a typical warehouse setup where we used to churn out drawings every day. It was one kind of job on age, probably 50 years ago, which shifted to smaller size sheets called drafting tables, where we used to make parts of drawings in different sheets. So that was the next step of evolution, how technology helped us from scaling the size. And then we came into something called a computer, which helped us to edit, modify, and copy all the drawings and all data digitally. So one of the major advantages of the digital revolution in architecture is that you could speed up a lot of processes. I mean, in case you want to design 5 buildings, it would take like 5 months to manually draw everything. And with computers, you could reuse, you could copy, paste, and create more drawings very quickly. So that is one of the aspects where technology helped architecture. And if you look at the picture to the right, this is one of the photos from a computer lab in an architecture school in Madhya Pradesh. So what we see here is people use computers very frequently these days, and we almost rely on computers to visualize and ideate our designs. But what has actually changed? How has technology actually helped us? For one instance, the only change which we can readily see is the change of medium. We used to do it manually over paper, and now we are doing it still manually on a computer. So what I'm trying to say here is the process is not efficient enough. In the earlier days, in the left side picture, the students, they draw manually using pencils, and if there is any correction, they have to do it again. And in the computers, they are still using their mouse and your keyboard to do digital drawings, yet manually. So the problem is in technology, the development of technology is always very fast, and it has exceeded the application rate in any industry for that matter. And construction and architecture industry is not very different in that aspect. So I like to illustrate this point with another concept. This is called the diffusion of innovation. So the first set of 2.5 is called the innovator set. what this graph essentially means is it calculates your market share of any technology that has been used or been yet to use. So let's take an example of robotics in construction. Not many of us know that it is even possible. Not many of us know how to operate it. And I myself am not very sure that I would know all aspects of how to create a robotic program to help me in my construction programs. So that technology still resides with the 2.5% of the population, that is the innovators. So you could probably see these kind of technologies in research labs and specialized studios or a few colleges across the world. Giving you a direct comparison with another example would be AutoCAD. I mean, everyone knows AutoCAD in these days, and that is why it's on the late majority, which means that the innovators, the early adopters, the early majority, the late majority, totaling up to around 80% of the entire population is familiar with AutoCAD. And to give you another point, the manual sketching, the one which you do with your pencil and paper, is on the last part, which means that it is kind of outdated right now. And that is the reason why the graph, the percentage of people using it has also decreased to 16% in total. So how does technology, a new technology, make way into the practice? So one way is you have to go forward in the curve. And that is where VR, virtual reality, and 3D printing is doing right now since its inception. So right now it's in the market. Not everyone is aware. Few are aware and few have started using it, but it's not the majority. And the majority would be IoT, that is Internet of Things. We use wireless devices every day, almost everywhere. And software which we can claim for architecture that has been widely used, we would call it as Revit. So that's just an example, not to name any specific tool. So the only way which we can afford to do to catch up with the development in technology is to go for mass adoption. The reason why we have to follow that is, let me give you an example here. See, at one point when AutoCAD was introduced, I think it was in around 1958 when AutoCAD was first invented or created as a software. It was not affordable. It was in the 2.5 innovators stage. And it was not affordable by a lot of people. But as technology was adopted by a lot of people, as computers and other electronic devices became more affordable, the AutoCAD or any CAD software started moving up the ladder, and now it is the standard, it is the basic for any kind of design. So only through mass adoption is how we can accelerate our involvement and usage of technology in any kind of field, especially in architecture. And one of the ways which we do when we promote mass adoption is through mass customization. And that is where parametric design is very effective, and that is one of the major specialties. So when we talk about why parametric design, as any question, anything we do always has to start with why. Let me give you another example over here. Let's say that today's task for us is to design a wine glass, just as something similar to the one in the picture. So what would be the first stage? We'll have to discover, meaning that we have to confine that this is what we're going to do. In this case, I've already told you we're going to design a wine glass. So that stage is completed. The second stage would be your definition. In definition stage, you will actually create your requirements, brief requirements, as in what will be the quantity, or what is the size of the glass, or why do you want to make a certain type of glass, what will be the function of it, what is going to be your maintenance issues, should it be easily washable, should it be disposable, all those intangible aspects. So the next stage is going to be where you develop the idea into something tangible for other people to express your ideas. In that case, it could be something like the dimensions, the size, or even the material. And the change in all these parameters or all these aspects which define your idea, or basically the parameters for your design. Once you fix on these, once you come up to a conclusion on any specific size as per your requirements, you go and give it to your manufacturer and you create prototypes and push it in the market. So this is the basic principle of how any product gets designed and gets launched in the market. And this is very effective. So there's no problem here, or is there? So the main problem in this process, this is a linear process. And the main problem in this is there's no scope for any modifications. And speaking of modifications, why would someone need to modify something that is already working and already in the market? Well, the question is, sometimes there are certain kinds of modifications that are needed, which doesn't change your function. Uh, let's take, for example, that you have several type of glasses that you want to design, which hold the same functional and intangible aspects that are required. Neither of the glass should be breakable. Every glass should be easily maintainable, easily washable, and it has to hold its required quantity of liquid. But there is still variation on the designs. So how do you compensate for that? The current and the usual process is we go back to the definition stage. That is where you create your requirements again from scratch, and you basically repeat the same process. So that is going to take up a lot of time in your definition process, and then you develop it and you come up with all the technical aspects like the material sizes and everything, and then you go back to your manufacturing process. So this is one of the drawbacks of the usual case scenario. Let me give you another example here. So one of the things which we'll have to notice is that in the wine glass example, the only parameters which we talked about was the width, the height, and the base radius. But in real life scenarios, it's not going to be as simple as that. In the case of a mobile phone, so we all know that the number of cameras are steadily increasing, and there is a reason for that, but let's not go into that. So let's say, for the sake of argument, the next iPhone is going to have 4 cameras. And what is that change going to implement? The first thing that is going to implement is your hardware change. Obviously, there's going to be another camera, another hardware going to come in. But that is the only modification you see on the surface. And most modifications you do to any kind of design or any kind of product often has its own complex implications. For example, software. The moment you add another camera, you have to redevelop your software so as to detect the other camera, and also to efficiently use all 4 cameras to provide you additional features. And the other important thing is it also affects other hardwares. As in, you're trying to squeeze in another camera, another component, a physical object into the same space without making any changes to the overall dimension or the thickness or the size. So that means the other hardware sizes and shapes are going to be adjusted, which means there is going to be a lot of rework. Even if the work on the surface level seems like you're just adding another circle. Putting that into the perspective of architecture, construction, and buildings, let's say that we are designing a 3-story building, a hotel probably. So each architect and structural engineers, they come up with a plan to design the buildings, the structural properties, and we usually go in a great depth. Like we go up to the size of the beams, the columns, the number of metal rods we use for the safety purposes. That is all part of the process, and that is one of the reasons why it takes a lot of time. Now imagine you have to scale up. Imagine you have to create another building with 5-story. So in this case, we know the same principles are not going to work here. We might need to add additional features, additional conditions. Maybe the height is going to affect the wind to the other places, or maybe the wind is going to affect the height. So there are a lot of other factors which are come into play. One of the simplest example would be your size of the foundation is going to change. The number of rods you're going to use change, and that is going to impact your structure, all your services. Probably if there is 5 floors, then you might have to look for an elevator, and your fire services has to be reworked, and your resources. So it's obvious that a 3-story building and a 5-story building cannot have the same number of bricks or the same amount of concrete. So reworking all these is going to take up a lot of time, and this is actually how the industry has been functioning all these days. But I would like to differ here in this point. What if, going back to the wine glass example, what if there was a certain way, a certain approach where you could actually control these specific things? In this wine glass, we had to control the diameter, the height, and the base. What if there was a way to control this with simply a knob, and all other aspects are taken care of automatically? I mean, one of the aspects which we'll have to consider in designing a glass is it has to be watertight, meaning your liquid inside the glass shouldn't spill out. And it has to be easy to hold. So that comes as a part of ergonomics. So what if you could design all those intangible aspects into something the computer can understand, something that can be automated partially? Wouldn't that increase your efficiency? Wouldn't that reduce your turnaround time? And well, I think so. And that is where parametric design is hopping in. So this is one of the greatest advantages of using parametric design, where you can automate a lot of processes. You can iterate designs depending on your requirements. So the first stage is like you have to gather all your requirements, what you want to do, what are your requirements, like tangible requirements, intangible requirements, based on which you'll create your logic and your rules. So this is where scripting and all your algorithms come into play, where you define your logics and rules. And the complexity of the logic and rule is up to the designer who designs the scripts. The more complex it is, and the more number of requirements it is, the more accurate your design would be. And based on all your logics, you're going to get your design output. And the beauty of it is your design is always going to follow all your rules. If there is any rule it breaks, then you're not going to get a design output. So you'll have to change your requirements for that. It also helps in checking whether your input and your output are in the same definition. So just to give you the answer for the class, we created something like a parametric model of the class, where we can change various inputs of the height, the radius, the sizes. And it automatically gives you the 3D model and the diagrams for it. So in aspect, like in what we are actually doing here is like, we're trying to, so what we're trying here is we are trying to make all these intangible aspects of design into a tangible one. So we're trying to convert all the things that you feel, things that you try to feel and think, into something mathematical and something which can be understood by the computer. Because computers are very good at repeating and iterating tasks. They cannot think, but we are good at thinking. We are not good at doing repetitive tasks, because there is always the factor of human error. So giving you an analogy, the left side image is showing you a usual expense sheet, probably a shopkeeper's, where he calculates all his expenses and income manually. And at the end of the month, he would use his calculator and calculate all this to get his net profit. So this is something like what we do in today's CAD. We just do it on a computer screen, but we still draw manually with a mouse, with keyboard, with specific dimensions. And on the other side, today's economics and accounts is advanced, so that you could just create formulas and spreadsheet templates, so that you just put in your updated values, or you can even make a copy of this and reuse it. And all your calculations are done automatically. You just have to define them once. And this is how parametric design at its core works basically. So to conclude what a parametric design is, it's not a specific style. Maybe when you do a simple Google search of parametric design architecture, you get complex and weird shapes. But there is actually a reason behind why those shapes are formed, and how that shape helps to the specific design problem. So parametric design works on the relationship between elements. In this case, the relationship was between the radius, the height, and the diameter, the overall size. So imagine if you could create an automated sequence or a process where just changing the number of floors is going to give you the amount of the steel rods or the foundation depth, the column, all the technical details are going to be generated automatically just when you have to change the number of floors. Isn't that gonna increase your efficiency a lot? So
Excellent.
So coming back to the application. So this is all theoretical as far as we are concerned here regarding the parametric design. This is all theoretical. So now we are going to talk about how this can be applied in real life scenarios, because in real life scenarios, there is going to be a lot of other factors which influence the design regarding practicality. And one of the most other things is constructability. So let me start with an example here. If you observe the photo on the left, there is a giraffe. And the giraffe skin has a specific pattern, which I request you to remember because this is going to be repetitive in a lot of slides. So this giraffe pattern is one of the common things which we see in a lot of other things in nature. To the right, I have a macro photo of a dragonfly's wing, where the scales on the wing also represent to the same pattern which we saw on the giraffe skin. To give you another example, the leaf structure on the left, when looked at a macro level, the veins, the patterns formed by the veins, they kind of represent the same pattern which we saw on the giraffe. And these are all totally unrelated examples, but they seem to have something in common. For example, the next image on the right side is a drought land. The other things which we saw were at least something living beings, but this is land. And the drought, which dries up the land and the cracks formed on the land, actually creates similar patterns. So there is something like a hidden logic or a hidden algorithm in nature. These logics can be decoded, and with a little bit of mathematics, we can actually recreate them in our designs. So the image on the left, the animation shows you how these images are formed. This is one of the logics, and recreating that diagram on the right side, we call it as a Voronoi diagram. So how are we going to use Voronoi diagrams in the practical life? How can they be constructed? For example, this is one of the test projects we did, an internal project at Modfive, where we created a simple algorithm based on the algorithm from the nature which inspired us. We created that and generated this pattern. To the right, you see how we tried to bring it to the physical world. We made something of a jali, a miniature jali version. And this design can be used in windows, or imagine this being your window or your doorway. So that is one of the applications. But that is not the only application of parametrically designing this. The greatest advantage is its reusability and scalability. These are a few examples. The first image on your left, if you observe closely, you can see that the shape, the pentagon's border is a very thin one in this place. And the number of cells are quite large. I mean, there are a lot of shapes filled inside the pentagon. The second image shows you that the border has now thickened and the size of the cell has also increased. There are also other examples with other polygons and a circle where you can actually control the size, the shape, the number of polygons, the size of the polygons. So what you modify and what you can modify depends on what kind of algorithm you create. That boils back down to your requirements in the first place. And using this in the practical world, this is a representation where the image on the left that you see, that is fabricated using a CNC machine. But if you see at the closer image, I mean the close-up on the right side, you see that the pattern still corresponds to the giraffe skin pattern. So in actuality, what we're trying to do here is we are trying to replicate the patterns that are already available in nature into our designs. And this is one of the ways. So how this works is you feed in an image through through your logic as your requirement, and it generates an Voronoi pattern based on the light reflectivity. So that is why where the person's hair and the dark spaces is, you see larger cells, and where there is light colors, you see smaller cells. So this is one of the logics of how this can be worked. And this is another example where the Voronoi diagram, the same principle, but in 3D has been used to create the base, the structural frame of a chair. So this is one part. And to the right, you have the same pattern that you saw on the wing of the dragonfly or the giraffe skin, which has been converted into a marble shelf. Can be used as a sculpture, can be used as your furniture. The design is totally up to you. The application is totally up to how we do it. This is another example where the same pattern which inspired us has also inspired someone else to create a facade paneling system. So this is the part of the facade that you see on the left side. And on the right side, you see the facade in action, where the entire facade is covered with all these small panels assembled together. And this is actually one of the projects, live projects in Mexico, where these surfaces help the city in purifying the pollution. So there are a lot of other uses also, but the main aspect which we'll have to reconsider is you only design once. Imagine an architect doing 100 buildings. He has to design 100 different times. But what if parametric design is feasible enough and it could be adapted by everyone so that you just have to design once? The algorithm which we design here can be used to create these shapes, can be used to create these images. And in this case, if you even substitute any image, my image or your photo, anything, it's going to create the pattern automatically. You can create furnitures, you can create facades. So the imagination is up to you. And this is one of the major things that drives us at Modfive Labs, our drive to modify things, to focus on reducing the modification time. So what we simply do is we create processes, algorithms, and scripts and plugins for other people. We combine with product designers, furniture designers to be specific, and interior designers and architects also, to get the requirements and market feedback. And also we collaborate with a lot of material engineers, fabricators and constructors, and other people in the industry, such as vendors also, so that we get feedback from the side of the practical application of these designs. So we try to amalgamate the artistic side as well as the technical side. And yeah, Seagrass is one of our ongoing projects. It's a parametric wall paneling design. So giving you a little bit of backstory. If you see on the first image on the left, you see that seagrass is just like a field of grass, but it's underwater. And the beauty of it is every time a fish moves or a shark moves, anything that in the water moves, it's going to create a few water currents, and that is going to distort this field. And it gives you a rippling effect or a wave pattern on the surface of the field. We were pretty much inspired by that, and so we tried to create something of that sort for interior designers and architects, so that they can bring in something of a fluidic design language with static design panels. And this is what we ended up doing it. So on the right side on the image, you can actually see that there are a few panels placed horizontally, and you could try to see the fluidic movement of the panels, in this case there are multiple panels and each panel is slightly moved. So in this case, what our parameters were to control our design were the number of panels, the thickness of panels, and the spacing, the height of each wave. And so these are some, to name a few. And we created an in-house plugin. That is how we got the name Seagrass. It's basically the name of the plugin. So in this case, what we are trying to do is we are trying to adapt it to almost any kind of situation by providing it with extensive modification. So one of few of the things which I like to explain is the length, the height, and the depth can be adjusted, which means that you could possibly do a 4 feet by 4 feet design, or a 10 feet by 10 feet design just by changing the slider, which means that you don't have to focus on creating the design by scratch. You can experiment and put in more time on finding the perfect design you want, instead of worrying too much about the technicality, provided you know how it works, obviously. And a few of the other things which we'd like to experiment in doing these panel design is the thickness, because the material, let's say we are designing it on wood. So wood comes in standard sizes such as 8 mm, 12 mm, 18 mm, and so on. So probably you could actually include the size of the material as an input parameter, so that your design changes depending on what material you use, and the spacing and other technical factors basically. So to the left, the first image which you see, you can see how the depth of the panel changes the effect of the ripples. So as the depth increases, your ripple pattern is much more evident. And as the depth decreases, you see that the pattern is receding and you get a plain wall. And one of the other things which we wanted to play around with was the position of the ripple. So this is one kind where you see the ripple moving along. You could freeze it at any point, and you could probably get that out as a design file. So just to give you a few examples, these are images of practical applicability of of a design we ended up creating from the seagrass plugin. To the left, we see that this is a part of the ripple which I was talking about in the earlier slide. So in this case, it is offset towards one corner. And towards the right side, this defines a more practical approach where you can use it as a backdrop or a desk, integrated desk for your office or your home office. And any specific modifications such as cutting out shelves or extra storage spaces can actually be done. And one of the major advantages which helped us in creating these panels was its automation to create the designs. If you see on the top, we have actually lined out all the panels. So this specific design you see here has around 43 panels, which means that you have to create 43 separate drawings for every modification you make. And that is going to take a lot of time if you're still using AutoCAD or any other drafting mechanism. So what we did was we tried to create another plugin for this, separate plugin to create all these 3D models into 2D drawings with support accessories, as you see on the right side image, so that these can be sent directly to your manufacturer for CNC cutting. You could go for wood, plywood, metal, anything. And the beauty part is, once you do any changes to any modifications to your 3D design, all your drawings are going to get automatically updated. And that is going to save a lot of time. So what essentially we are trying to do here is we're trying to cut down the turnaround time for modifications, because when you go for mass customization, there's going to be a lot of modification. And in this case, you go directly to your development stage once you modify, because all your drawings and your technical details are already a byproduct of your design. So once you do any kind of modification, it's going to push you directly into the develop and deliver phase. So this is something of an implemented project by one of our fabricators in Indore. He's also a part of this audience right now, Mr. Pratik Sharma. So in this design, this is also a part of testing out the idea, where these panels were fabricated using parametric design, something what we're talking about. And this has been used as a reception table. There's, you can see on the second image. So one of the advantages of using parametric design is its scalability. So as we said on the Voronoi diagrams, you could use it for either a furniture or a building. It's totally up to you. So we started with the wall panels, and now we are looking into false ceiling. False ceiling is the first image on the left side. You could probably do this on your cafeterias or your restaurants. So this is one aspect which we are yet to explore. The second would be freestanding furnitures. This is actually a small coffee table. The glass on top is yet to be placed. You could do freestanding structures, or you could still use it as a column cladding. The limitations are endless. It's totally up to how you go on. So this is one of the famous aspects of parametric design. Everyone thinks that parametric design always has to be complex with mathematics and logics. It can also be very simple. And to illustrate that point, I'm here to present one of my favorite architects' projects. So this is a cafe, and it's designed by a Mumbai architect, Nur Karim. So if you see on the left picture, you see that these black wavy portion of the building, that is actually the facade of the building, is designed for one reason: to mimic the nature and biology of human hair. So that's why it's black. And the other part is the functional aspect of it is to include privacy, because this is a cafe and people are going to be sitting inside. So they probably don't want people from the outside staring at them. So on the image to the right, you see that each and every point or every dot on this facade is actually a pipe, which means that these patterns are created through an algorithm. That is a bit complex, yeah, but you can also use it by just using a pipe, just that the pipes are cut at different sizes and placed systematically. And this is one of the views from the inside the cafe, where you can see all these pipes aligned and fitted on the glass panes. So in actuality, it doesn't hinder your light. It actually provides good lighting inside while still giving you the privacy from outside. This is a close-up of the same facade where you see all the different lengths of the pipes placed here. So the simplicity or the complexity of the parametric design, it entirely depends on who designs it and how we design it and what are the number of modifications we give it. So coming back to the earlier slide, what has actually changed from the earliest type of design practice and today's design practice is that the only aspect is that we have started using computers, and the reason we moved to computers is because of its modification ability. You want to copy something, you can do it in a computer. You want to edit something, you can do it on a computer, and you don't have to worry about spoiling a sheet or tearing off a sheet. So that gives us some flexibility, and I think parametric design also gives you a highly advantageous edge over the existing CAD or technology. And I like to end with a quote from one of my favorite inspirations, like Charles Darwin. He says that it is not the strongest of the species that survives, not the most intelligent. It is the one that is most adaptable to change, which means that architecture today is actually changing. And one of the problems which we face is we are not able to adapt. And the other technologies which influence architecture, which can influence architecture, like 3D printing. Right now, it's one of the biggest thing. And during the COVID pandemic, 3D printing has helped a lot of people in the medical industry. That can also help architecture if we let it. Other aspects such as data science, Internet of Things, can all help in upgrading architecture to what it actually can be. Talking about virtual augmented reality, that is one of the greatest things that has ever happened. You can visualize, you can live in your own home before it is even built. No other technology allows that. And we are slow to adapt that technology because of our differences. The only way to adopt all these technologies into a practice is to push for mass adoption, and in hopes that our new technology move from early adopters to early majority. I'm talking about the diffusion curve. And now is, I think, is the right time to adapt. Thank you.
Thank you so much, Kaushik. That was really, really insightful.
Superb, yeah. Very good designs, and I think it's a very different way of understanding how architecture or how products could be managed nicely.
Thank you.
Based on this, we have a lot of questions since we had posted this topic to a lot of places and groups. A lot of questions which have come from a lot of groups,
Okay.
which I would want to post it to you so that you can explain further. Very basic questions that come.
Okay.
The first question that has come to us is parametric design a brand new technology today, or it has been there for some time?
Okay. So, as I said, parametric technology is, and no technology is brand new. Once you see it, it's already on the market, then it means that it has crossed the early adopter stage, and that is why you're seeing it. So if something is brand new, you won't see it. And a good example would be for that is robotic construction. You don't see any robots constructing any buildings in India or any matter of, as a matter of fact, in any part of the world right now, because they're still being developed. So to answer your question, parametric design is not a new technology. It's been here. And there are a lot of firms that are actually adopting this practice and coming out with great efficient designs. Yeah.
Thank you. Thank you, Kaushik. Kaushik, we have a few questions coming in from the participants first.
Okay.
We'll like to take that up first, and then we'll go in with the questions from the various other groups.
Okay.
Now, I don't have a name here, but then the question is, how can one learn this parametric design?
Okay. So parametric design, it's basically deals with, there are a few components to this. One aspect is you have to know why you're drawing that line, why you're, anything you draw on the screen, it has to have a purpose. That is one of the basic mindsets you need to start learning parametric design. And not to name a specific tool, I would say, but learning a little bit of scripting, probably Python or Visual Basic could help. I mean, any CAD software you use today AutoCAD or SketchUp, anything that is going to have its own scripting platform. And that is how you automate things. So that is one of the basic starts to parametric design, and then probably you could develop with other softwares too.
Thank you. Thank you. I hope that answers the question. Next, we have Mr. Vijendranath Ravindran. He wants to know first, he has two questions. He first wants to know the source of the diffusion of the innovation graph,
Okay.
which you had used in your presentation.
Yeah.
He wants to know what is the source of that graph. How do you arrive at that particular graph?
Yeah. So the diffusion of innovation is a graph that is developed by economists and data scientists over the past around 20 to 30 years. This is basically based majorly on observation and occurring trends in the market. And these have just been put into simple terms for easy understanding. That's it. And one of the major people who promotes the diffusion of innovation curve in his almost in every speech, I would recommend watching Simon Sinek's speeches probably, because that is where he gives you the reason why you have to start any of a design with the question why. And that is one of the major questions that leads innovators. And to answer your question about how this can be, the previous question is I need to know parametric design. Parametric design was developed actually by a certain set of innovators probably 50 years ago. So now it is available in the early adopter stage because it was taught and preached to other people also. So that is, I hope that answers your questions.
Thank you, Kaushik, again. And the next question from again Mr. Vijendranath Ravindran,
Yeah.
which will also to an extent answer Mr. Yashwant's question also. So he asks, do you see a live or a real-time application and monitoring of the system that you had explained? So, and again, Yashwant also wants to know if parametric designs can go to some further extent, as in is it limited only to facades, or we see the designs often online, or limited to those, or it can further be extend those?
Okay. So coming back to Mr. Vijendranath's question, the practicality of the design is also another, if you ask me, it's just another parameter for a design. The cost and the fabricatability, so as to speak, of aspect of any design also comes up with the current technology available. So if you ask me, when we developed the seagrass panels, just give me a moment. So when we developed these panels, we took into consideration the fabrication possibilities which we had. And one of the things which we had to take care was this cannot be done manually. Let's say that in this design, there are probably some 20 or 30 panels, but in a huge facade case scenario or another kind of design, there are going to be around 100 to 150 different panels. So technology really plays a huge part in how affordable or non-affordable this is. But that is also one of the reasons why we are trying to push the technology of parametric design from the early adopters to the early majority so that it becomes more affordable. To give you another example, 10 to 15 years ago, if you see the development of phones and computers, digital technology to be specific, it was not very affordable. Not many people had touch phones, not many people had digital phones, only a certain section of people who developed, who were testing the idea, had access to these. And fast forward now to 15, 20 years, almost everyone has a touch phone. Almost everyone has access to a high-speed computer, high-performance computer. That is all because of mass adoption of the design and believing that it will all work out. And yeah.
Cool. I understand that. In fact, like I said, when the phones were launched of incomings rather than the hardware, even the service used to be so expensive.
Yeah.
You used to be charged for incomings too. Yes. And the next question, Kaushik, is from Mr. Naveen.
Yeah.
And that is also a part of the question of the survey which we had done. The
Okay.
the parametric designs look complex and expensive.
Okay.
So, are they commercially feasible?
Okay. So as I just mentioned, I think commercial feasibility is also, it can be treated as another parameter. Let me give you an example. Let's say that we have to design a panel, and in this case, we'll have to make it commercially feasible. So what we have to do is, like, let's say that this is a
I'm sorry
panel,
to interrupt, but
right?
I guess he missed the part of the question.
Okay.
I question like, do you think that the wastage of the material is going to increase because the parametric design is quite complex,
Okay.
and the material that we use, at the end of the day, it increases the wastage of the material that we use. What's your take on it?
Okay. So this is actually good question. So this is one of the questions which we were asked by one of our suppliers. So currently we are tying up with a few companies in UK where we wanted to ship our panels, prefabricated and manufactured panels to UK for their local market. And one of the key components which we had to work on was the material wastage and the cost. And just to give you a brief idea about how it can be tackled in case of these panels is that we came up with a symmetrical design. So a symmetrical design solves a lot of complexities. This portion, the left side portion, can be used as a panel A, and the right side can be used as an inverse of A. So in a sense, you get two panels from the same design, and that is increasing your efficiency to twofold. Of course, this is only possible if your algorithms support it, which means that you have to think about this early on when you're designing your processes. And one of the other aspects is that the accuracy of the cut, in this case, since we are using CNC machines, the accuracy can actually provide us with the other side without any wastage. But in case we are employing physical, like humans, to cut it out manually, then there is a possibility that materials can get wasted in the second half.
Cool. Thank you, Kaushik. So I hope that answers your question, Mr. Naveen. Use it at an early stage. Keep it in mind while plugging in the algorithms, and then you, in fact, rather end up saving it than being it on the expensive side. The next question we have from the survey is
Ankur,
how easy it is maintained to. Yes, Rohan, go ahead, please.
Sorry. I just wanted to ask a question on the same line which he had asked for on the wastage part of it. But from one of the parametric design which you had shown of an architect from Bombay,
Yeah.
is using pipes. So yes. Even if there is a wastage in the pipe, if I'm getting such a beautiful elevation on overall design, I wouldn't mind having a wastage, because we have seen elevation designs for crores of rupees people spend on elevation. And with the design which you had shown me, though it looks very, very expensive and stylish, but when I zoomed that picture and saw they were regular pipes.
Yeah.
So I mean, if there is a part where we discuss about the wastage, but there is always a part where we discuss about economical application, but it still gives a stylish look. So this is not a question, but to answer, I mean, I feel parametric design could also help us in utilizing products which are, I would say, cost effective also. So wastage will not be a concern in few of the designs, I feel. Yes.
Yeah. It comes down to how well you practice the same approach while in the initial stage of designing your algorithm specifically. I like to add something here with this same facade for the Bat Cafe. So if you notice that we all know that pipe is a linear element, meaning that it has only length, keeping the diameter fixed. So any wastage in this place is going to be reused in another place, because the length is the only factor that is changing in all the places here. So if there is any small piece left out, that can be used on a smaller area, or if there is any large piece left out, that can also be used in a place where the length is required.
So just wanted to understand these, I mean, when you design, I mean, for such facade or anything with the help of pipe, do you get the exact quantity out of it? I mean, that I would need 3 inches, 4 inches, 5 inches pipe, 6 inches pipe, 7,000 pieces, 8,000 pieces. You get those exact numbers when you design, or these are based on the application.
You get the exact numbers, and even you get the exact quantity of, let's say that you have this entire wall. Let's say that you are designing the same wall. You can actually get, I need 12 numbers, 1,200 numbers of 12-inch pipe and 3,000 numbers of 2 inches pipe. You can get it to that accuracy.
Okay. I think it's a brilliant design. Yes, that answers the question. Thanks, Kaushik.
Yeah.
Yes, Ankur bhai, you can go ahead. Hello.
Yes.
Yeah. So I think we have a question coming in from Rahul Sehwag. He wants to understand the parametric designs are scalable. He wants to understand what exactly scalable mean here. I mean, the ease of scalability to the existing design or something, or is there something else in terms of scalability? And the second question is parametric design a cost-effective solution? I think the second question is answered, depends on the design. But the first question is, by scalable, it means, is it very easy to scale it and understand how it will look in a larger scale, or it has got to do something with existing designs? He wants to understand.
So scalability here, what I'm talking about exactly when I mean scalability is you can do it, you can use the same design, the same algorithm for smaller objects or even the larger objects. So scalability here, I'm meaning it literally when you scale the object, as in this case where I'm making a small replica, a scale sized model of it, while the same design can be used on the entire building. So in effect, you're designing the code, you're putting in the effort only once, but you're getting the output multiple times. And the other aspect is, if I want to create 100 different buildings with the same kind of design, I don't have to rework on the designs again. I can use the same script, I can use the same logic, the processes. I just have to change the input parameters, probably the length, the height, and the depth, or other whatever parameters that can be modified. And I get the output, I get the required output from that. And yeah, I'm sorry, what was the second question again?
Second question is parametric design a cost-effective solution?
Okay.
Yes, that more or less you have answered already.
Design it. You can do it for low cost, you can do it for expensive versions also.
It depends on how anybody wants their design to be. Yes, that is understood. Okay.
So we have a very interesting question, Rohan, here from Vivek Goel.
Yeah. Okay.
Hi, Kaushik. Vivek here.
Hi, Vivek.
I think you can ask the question directly, Vivek.
Actually, I posted it. When we use the algorithm repeatedly, one is like, is there a patent for it, or does it, the person who designs it owns it? Who owns the actual, the thought process? Because let's say you have come out with this, what you're talking about, the seaweed, right?
Yeah.
The seagrass.
Seagrass, yeah.
Now, let's say you have designed it.
Okay.
Now, as you said, repeatability is the one which actually adds value to this process, right?
Yeah.
But where is the patent, and how does it infringe on the other person using it?
Okay. Yeah, I understood the question. So, let me give you an analogy to that. We learn Pythagoras theorem, we learn differential calculus in our school days. So, who owns the calculations? I mean, who owns the part?
No, see, there is a difference between theory and business sense. See, most of the designs which we talk about, there is a business application to it. A patent is only applicable when you come out with a unique business application. That's the basic premise of a patent. See, I understand that Pythagoras theorem is universal. The Newton's law is universal.
Yeah.
But if I come with a commercial application, I can patent it. That's how the patent law came into being.
Yeah.
So whatever we are talking about, at the end of the day, we are all businessmen. We are looking at the commercial applicability of any design we are working on. Why will I invest on it, or why would even I think about it? It's a cost for me.
Okay.
That's why this question specifically.
Yeah, I understood. I got your point. So the actual skill which you need to use here is not on the theoretical part. It's not on the practical part. It is actually in comprehending the both and making your script or whatever product you create reusable. So right now what we are actually doing is we also sell scripts to people, or we also do the design as a service. When we are selling the scripts, we don't provide them the source code. We only give them a use and a usable copy of the software, which means that they can reuse it to create certain kinds of designs, but they cannot reuse the code or modify the source code. And that way, partially our material is also protected. And when you're talking about the scalability, the repeatability, anyone can come up with any kind of algorithms. It's just the field is that broad, which means that there are possibilities of overlapping designs and overlapping algorithms. Some might be more efficient and some might be less efficient.
See, I mean, to put it in another word, you own the IP. Basically, if you're talking about a software IP, it all comes down to that you are the basic owner of the IP and you license it in a way.
Yeah.
You don't give the IP with the source code to anybody. So if I have to come out with a concept, like I'm in the marble industry, the idea is like a lot of facades, if you see huge applications already being done for the marble industry. So if I have to develop a concept, then I can own the IP. It's up to me to share that in terms of how I want to license it or how I want to create a royalty out of it, right?
Yeah.
Yep.
So you can still do that in this case also. It depends on whether you give away your plugins for free or whether you sell it at all in the first place. So a few people who I know, they don't, they create in-house plugins for their own companies, and they do the design output as a service, which means that the end user or the end client is not going to know about the process. And looking from the outside, it's going to look like a beautiful building, and only the actual architect knows the amount of work or how smart he worked. So it's parametric design. It focuses not on the output, it focuses on how you do things, how you create the process, how you make it easy for yourself. So the end product, to give you another example, the seagrass wall paneling, which we are actually doing right now, that can also be done by manual CAD. The only advantage which we have right here is the ease of modification. In case I want to create any specific pattern, I can do it very quickly. So I hope that answers your question.
Sure, thanks, sir. Thanks a lot.
Excellent. Kaushik, continue to this question. I wanted to understand, is parametric design restricted to a particular type of a material, or because what I understand from Vivek is, since he's into marbles and granite, he wants to understand if he can develop a design along with your company or with anyone who can design parametric ways of working so that he can sell it like a concept. Do you think it is feasible to have parametric designs with different fields? For example, Ankur is into woods, plywoods and veneers. I am into lighting, and there are a lot of people into different arenas. For example, there is one guy who's into wooden flooring. So can something like this be, I mean, this parametric design, would it be applicable for any kind of a material, or it is restrictive?
It is not restricted. It is only restricted as much as we are restricted in our thoughts. And parametric design, as I think we had an introduction session where one of professors from Hindustan University mentioned that we use parametric design in the mechanical engineering field. So parametric design can also be used to design buildings, products, cars. Today's aeroplanes and rockets use the same technology, parametric design, to create complex systems. So answering your question, it is entirely possible to work with a wide range of materials, with a wide range of technology in multiple fields.
Okay, great. So we'll move on to those questions which we have received from different forums. The one question which we have received is, how do we start learning parametric design techniques? What skills do we need to learn parametric design techniques? Is there any software, or is there any course, or is there anything which we have to see? I mean, they want to understand that.
See, learning parametric design is, how do I put it? So parametric design is just a concept which you can apply in almost anywhere. To architecture and to design, this is a little bit new. If you ask me, even using a spreadsheet, Excel is a kind of a partial application of parametric design. in order to start using it, I would suggest not depend yourself on any specific tools. Just start asking the right questions as to why you're designing and why a form or why a special shape is designed in such a way it is. And if you want me to name a few tools, probably could start with Grasshopper, or different softwares have different things. You can go for, if you're using Revit, you could probably go for Dynamo or Marionette. There are a couple of softwares you can just do a quick Google search would probably get you all those facts as to the software part. But if you're asking about what I should be prepared to do, I think you have to put in a lot of hard work and learning how to think, because the usual style of designing is always output oriented and it is not process oriented. When you're starting to think parametrically, your thinking has to focus more on the process rather than the output.
Okay. Excellent. I mean, the last question which had come to us, we received around 11 questions, out of which most of the questions are answered with your presentation and what other people had asked for. The last question which people want to understand is, what is going to be the scope of parametric design in India? What is it futuristic, or how it is going to be? What is your take on this question? What is going to be the scope of parametric design in India?
Parametric design is, India is actually late in picking up the trails of the breadcrumbs of parametric design, if you ask me, especially in the construction field. So there is a lot of scope. It depends on the economic side also. And I mean, the current stage of the economy doesn't allow any kind of factories, or it literally doesn't allow us any kind of experimentation. So that is one part. But if you're talking about the future, there is definitely a lot of industrial applications, product design applications, especially in the material, lighting, and fixtures that support architectural design. So probably not entire buildings very soon, but we could look forward to other specific objects such as window designs, jalis, small objects which come together as a building.
Okay.
So much, Kaushik. That was really, really insightful.
Yeah.
Being traders, actually, we felt. Yeah, sorry, Ron. Being traders, we actually we actually found it so interesting. I wonder the students in the group, it would have added real value to them. And the kind of the way you have handled the questions, all different bouncers from different angles and different areas, you handled it like a pro.
I mean, that's one of the advantages of hosting a webinar. You get different perspectives about the same thing. Questions are good.
Excellent. Super. So I think we come to the last portion of this webinar, wherein since you've been a very good guest to us, you've been a very good special guest to us. So you would have to know who have come to see your webinar. So I would request Utsav if you could,
Sorry to interrupt. There's a question from Sam. I guess this is the last question we'll take in. Don't want to disappoint anyone.
Please.
So he is asking, Sam, are you there online? You can ask him directly. Hello.
Yeah, hello. Hi. Hi, Kaushik. It's a really good seminar overall. Thank you, organizers who made this possible. And Kaushik, I wanted to know that looking at this current stream, that how wide it is and how of an high impact it will have in the near future. As you already showed in your innovation curve, division of innovation curve. In the near future, the current trend, like how it is being taught, architecture is being taught, like how much of an impact it will have on educational system, like how far it will lean towards that, because currently it is, since it's already there, but we know most of the people don't know about it. So how far it will bend towards that, and suppose if and looking at the near future, and this has a wide impact, like when is the right time to get someone introduced to this? So suppose I have a school friend, a junior who's studying school right now, is in 12th or higher secondary or in 10th or 12th. So when is the right time for me to introduce him about coding, about this and that, and when is the right time for him to get into parametric? Thanks.
Well, there is this Chinese proverb which says the best time to plant a tree was 20 years ago, and the second best time would be right now. So parametric design is it is growing right now, and in the educational field, if you ask me, it all boils down to how well we apply those technologies in our day-to-day practices. Because education, its responsibility is trying to bridge the gap between the industry and the students. So basically, it's trying to fill up the gap and helps the students to get a start on their careers for any kind of design. And the earlier you get exposed to any kind of design or coding or whatever skills you mentioned, the earlier it is, the more time he or she has to think about it and try to connect the right dots. And hopefully that will help them.
I think that answers the question really well. Thank you so much, Kaushik. I think it was a great webinar. It was a great learning for all of us. And I'm sure a lot of people who are into various fields of business and various trade would want to understand how they would be able to apply parametric designs in their products so that they can provide something unique to their customers. I think most of them would want to get associated with you, or most of them want to get in touch with you with regards to this. I'm sure it is going to be a very good collaboration for all of us. It was a great presentation. I would like to thank Utsav from Vibrant Furnishings, who has
My pleasure.
who has been instrumental in hosting this entire webinar. And I would do Ankur from Wood Story, who had also helped us in moderating this entire event. Thank you so much, both of you.
Thank you.
And I would like to thank everybody who has attended this webinar and had made it possible. Very, very interesting, very, very useful thoughts flowing into our minds. I think a lot of innovation is going to happen with parametric design in India. Yes, we are hopeful.
Thank you.
Kaushik, you want to end up with saying something, Kaushik, to all of us?
I think I'm not in the right position to give ending notes, but I think that any technology is only limited by how much we use it and how much we get dependent on it. So my advice is don't get stuck with any specific software or specific methodology. Parametric design is something that is working right now. That is something that is in trend right now. Keep your mind open, and the future of architecture, 100% it relies on collaborations. The more you work with different people than in your own industry, the more exciting ideas you get. So don't limit yourself. Thank you.
Thank you so much. Thank you, everyone.
Thank you, Kaushik, very much.
Thank you so much.
Thank you, Rohan bhai, and thank you, Ankur bhai.
Thank you. Thank you.
Thank you, sir. Thanks for the opportunity. And I would like to thank everybody who is present for today's webinar. They have taken out their precious time.
And if you can
special
take a
thanks
couple of
to
more
Kaushik.
minutes. Yeah, sorry, Rohan.
Yes.
If you can take a couple of more minutes and fill in the feedback, it would really be of great help for us.
Absolutely. We have made a survey link. We have sent the link on the chat box. I would request if everybody could take few minutes and just fill in those survey. It'll be a great help. And your feedback is extremely important. Thank you so much, everybody. And thank you so much, Kaushik, for participating again. And
thank you, Utsav. Thank you, Rohan and Ankur, for hosting this. And it's actually a great opportunity for me to express my ideas and opinions. And it is also exciting to see a lot of interesting questions, which I hope I answered most of your questions. But in case you still have any questions, I think most of your people know how to reach me. So I guess that's not going to be a problem. I hope it was helpful.
I would request Utsav that if to anyone who wants to get in touch with Kaushik with his permission, obviously, I would ask people to get in touch with Kaushik for any of their doubts or any of their projects which they have thought of, and let's come up with something and let's innovate India. That is the thought which I have before ending the webinar. Let's innovate India and let's get parametric design into place into all the concepts. Yes.
Yes, true. We should definitely do that. Even in a small project.